Hello and welcome to Cloud Native with Confidence, 4 key requirements for Kubernetes ransomware protection. Today's webinar is sponsored by Veeam and produced by Actual Tech Media. My name is Scott Becker. I'm from Actual Tech Media, and I am excited to be your moderator for this special event. Now, before we get to today's great content, we do have a few housekeeping items that are going to help you get the most out of this session. First off, we want this to be an informative event for you, so we encourage any questions in the questions box in our webinar control panel. Not only will we have team members responding to questions during the live event, but we'll also have a dedicated Q&A session at the end of the presentation where we'll discuss in greater detail some of the top questions that you have. A Q&A panel is also the place to let us know about any technical issues you might be experiencing. A browser refresh will fix most audio, video, or slide advancement issues, but if that doesn't work, just let us know in the Q&A and we'll provide further technical assistance. Now, second, in the handout section of your webinar control panel, you'll find that we're offering several resources. There's a For Dummies book on Kubernetes backup and recovery, and a paper on 7 critical reasons for Kubernetes native backup. We've also got a PDF of the slide deck for today's presentation that you can download. Also in there are a link to the Gorilla Guide Book Club, where you can get access to Actual Tech Media's great printed resources on technology topics, as well as a link to the ATM Events Center, which has our calendar of upcoming events. So I encourage you to access those resources now and share them with your friends and colleagues. Third, at the end of this webinar, we will be awarding a $300 Amazon gift card to one lucky registrant. Of course, you must be in attendance during the live event to qualify for the prize. The official terms and conditions of today's prize drawing can be found in the handout section. Scroll to the bottom and you'll find the prize terms and conditions link there. Finally, one of the best benefits of this event is the opportunity to ask a question of our expert presenter. To help encourage your questions, we have a special additional prize for you. That's another Amazon gift card, this one for $50 for the best question. After the event is over, we'll look at all the questions that came in, pick out the very best one, and contact that prize winner. And with that, let's get to today's fantastic content. It is my pleasure to introduce our presenter today, Jeff Reichert, who's Vice President for Public Sector and Compliance Strategy at Veeam. So I'm going to turn things over to.
Hello, thank you so much for joining us today. My name is Jeff Reichert. I work in the Office of the CTO at Veeam Software on the Product Strategy team. And in my role, I focus on a couple of different challenges that our customers face. The first of those challenges is compliance, and I work with customers facing compliance challenges, whether they're in the public sector, in the private sector, whatever vertical they may be in. And as a lot of you all probably know, compliance challenges tend to be getting more difficult to navigate, not easier to navigate with every year. And then I focus in particular on the challenges that our public sector customers face. Today's webinar is, of course, an intersection of both of those because we're going to be talking about the ransomware security challenges that state and local governments and educational organizations are dealing with. And in particular, we're going to be looking at those challenges through the lens of risks to your Kubernetes environment. Now, many of you all probably saw that before today's webinar, we distributed a survey where we asked exactly what you would like for me to cover in today's talk. And we had a few respondents who said they'd like a broad overview of containerization and Kubernetes, but that was in the minority. Most of the folks who responded were already familiar with containers and Kubernetes, and they requested that we talk specifically about the ransomware threats that Kubernetes faces and how they can mitigate those, what the requirements are to make sure that you have a robust and ransomware resilient Kubernetes environment. For those of you who wanted a broad background, I am going to do at a very high level, just a couple of slides at the very beginning, a quick overview of what containerization is and what Kubernetes is. But we're going to have some links at the end of the webinar that you can look at if you'd like more of a background on the technology itself. We're going to be going at a little bit deeper level today, looking at specific challenges and some specific ways to remediate those challenges in your Kubernetes environment. So let's go ahead and jump right in. When we talk about the rise of Kubernetes and Kubernetes as an orchestration platform, it's helpful to start with the idea of containerization. Now, when we list a slide that has, like this one does, a timeline to containers, it might kind of imply that physical servers, which are on the left, are going to die off like dinosaurs, and that ultimately containers will be the last things standing. Veeam does a lot of research on where the market is around adoption of various data platforms and compute platforms, and that's just not the case. There are some things, I'm sure, in your data centers that are still running on physical servers, and there are things that are running on all the platforms to the right of those too. If we look at this timeline, what it lays out for us is basically the evolution of compute since the mainframe era, when we had applications running on individual servers. And of course, most of you all are familiar with rack-mounted servers. They shared an underlying operating system, one per server, and I would have various applications running on that server in the same operating system that, generally speaking, could see and interact with one another. The virtualization revolution, first VMware, and then of course Hyper-V, Nutanix AHV, KVM on Linux platforms, took the level of abstraction one step further from the world of physical servers. What we got with a virtualized platform, as I think probably everybody on here knows, is the ability to abstract the operating system from the underlying physical hardware, so that I could now have multiple operating systems running on the same physical hardware. I could drive a lot more utilization of those physical hardware resources, because if they weren't being fully utilized, I could spin up another virtual machine on them. And those virtual machines obviously could have different operating systems, different applications that either did or did not interact with one another. The advent of cloud computing, whether we're talking about hyperscale cloud on AWS or Azure or GCP, or whether we're talking about cloud at a local managed service provider, took the level of abstraction one step further, because now I'm letting my service provider handle things like my physical hardware provisioning, my storage provisioning, my physical network provisioning. And I'm handling all of that at a virtualized logical layer. So basically, it's one step further up. Back when I had VMware in my data center, I did still have to manage the physical hardware, the physical networking, all of that. Now I'm letting a service provider do that for me, and I've abstracted what I need to deal with a little bit closer to the specific applications that are actually driving the mission of my organization, whether it's providing government services to citizens or providing education to students or whatever it may be. Containers are just the next logical step in that progression. With containers, we have physical hardware sitting underneath. We have what looks like a physical or a virtual server sitting under a container runtime, and that could be something like Docker, Containerd, or various other ones. But we have only one operating system that is sitting under that container runtime. I'll take an example. Maybe I'm running Ubuntu Linux under Containerd, sitting on a virtual machine. And on top of that container runtime, I've got multiple containers, multiple services that are running that draw on libraries that are very, very granular and very, very easy to move around. Containers provide sort of the next step in application portability, in the ability to have discrete small services very efficiently running on the same physical or virtual hardware. They provide the next step along in that compared to virtualization. And obviously, even though I'm showing this basically sitting on physical or virtual hardware, there are, as I think all of you all know, various container as a service or Kubernetes as a service platforms that are out there that let these be provided as a service as well, so that basically all you need to worry about is your actual application workloads that are running in that containerized environment. Now, we're using the example of the progression from physical to virtual servers to talk about containers themselves. For those of you that, for example, use VMware in your data center, it's not going to be a surprise when we describe Kubernetes, which is a container orchestration platform. It's the leading container orchestration platform, as basically being like the vCenter of the container world. Just like I use vCenter if I have a VMware environment to handle the provisioning of all kinds of resources to my virtual machines, to handle security, to handle what my policies are around failover and resiliency and redundancy and replication in the environment. Kubernetes performs all those functions, but it performs them for containers. Now, Kubernetes is not the only orchestration engine for containerized environments, but it is the industry's leading one. It's the one we're focusing on in today's webinar, and it's also the one that Veeam's product around protecting containerized workloads focuses on, and that's kasten K10. The key thing to think about when you think about Kubernetes is basically, I'll get a little bit into the weeds, it's declarative model. You don't have to worry about starting up every instance that you want to run. You don't have to worry about doing that. You can basically tell Kubernetes in code, this is the instances, this is the number of instances that I want to run. And if one of them goes down, it's going to start those up again for you, right? If something goes wrong, it's going to monitor the health and take action based on what you've told Kubernetes that you want to do. And that's the real strength. Again, kind of similar to the policies that you would set up in vCenter around managing the health of a VMware cluster. So that's the super quick view of what containers and Kubernetes are. We're going to look now at where both of those technologies sit in the market. Veeam is one of the leading enterprise data management and backup companies in the world, and we do a huge amount of independent original research every year around what's going on with data, where our customers are keeping their data, how they're protecting it, what challenges they're running into, what they'd like to see next from Veeam and from other vendors in the data protection space. This year, we surveyed 3,400 organizations worldwide. We did that through a professional survey firm, so the organizations responding did not know that they were responding to Veeam. They just knew that they were being surveyed. Most of the organizations that we surveyed were over 1,000 employees or staff members, and they represented organizations in every different vertical. A lot of public sector and education, but also private sector, financial services, healthcare, et cetera, et cetera. What we found out when we surveyed them was that fully 56% had containers in production right now. The ones that didn't have containers in production were another 35%, which meant that we had only 9% of 3,400 folks that we interviewed worldwide about this that didn't have containers either in production or were planning for containers. And we had exactly 0% that said we don't have containers in production and we have no plans to implement them. So the upshot of this is that while the physical servers in your data center, your virtual servers in your data center, your cloud workloads are probably going to be around for the long haul, it is also very likely that if you do not have containerized workloads and Kubernetes in your environment already, you're going to have those things in place very soon. Of course, today's conversation is about ransomware, and so it's worth pointing out that ransomware adversaries have noticed this trend. Gartner has predicted that by 2024, 70% of organizations, so that's again about 15% up from where we are right now according to Veeam research, will have containers running in production in their environments. That is a number that ransomware adversaries and that malware adversaries pay very close attention to. If you've watched the news, earlier this year, there was a survey of 1,000 Kubernetes environments worldwide. The survey results were that of those 1,000 organizations, fully 86% had experienced ransomware attacks focused at their Kubernetes environment. One of the most troubling things about this survey, though, was that in the same exact pool of respondents, only 33% had Kubernetes-specific backup methods in place. Now, I say Kubernetes-specific backup methods. We're going to talk in more detail a little bit later on in the talk about why it's important that as you roll out applications that are containerized, that are running in Kubernetes, that you have a method to protect those that is also specific to that environment. Kind of similar to what a lot of you probably saw when you adopted given database platforms, or certainly when you adopted virtualization platforms like VMware, Hyper-V, KVM, Nutanix, AHV. There's a giant night and day difference between actually protecting those platforms with tools that are designed for them and trying to cobble together solutions based on other capabilities. I'll just add a couple of more news points from this year. There are in the news already, and in fact there have been for years, documented malware attacks specific to cloud-native Kubernetes components. This is a news article from last summer. Argo workflows, which are a very commonly used open source suite of products that help developers deliver software rapidly and safely. You can roll out your updates, and you can roll them back if there's an issue. Very common in Kubernetes environments. There were some vulnerabilities that were being exploited in Argo workflows for crypto mining, specifically Monero crypto mining. I mentioned that these exploits have been around for a while because way back in 2018, none other than Tesla, which is a pretty technologically sophisticated organization, discovered that certain Kubernetes configuration vulnerabilities in their environment were being exploited for crypto mining 4 years ago. There was another story, probably a lot of you all saw last summer as well, about the Hildegard crypto mining exploit that was targeting Kubernetes environments as well, also to do Monero crypto mining. So this is not new. This is being reported in the news. And as we've talked about, because of the growth, both already and in the future, of Kubernetes in production environments, attacks are going to escalate further. This is a quote from industry analyst Johnny Yu. Johnny Yu is a research manager at IDC, which is one of the largest global industry analyst firms. His quote kind of speaks for itself. I won't read it to you, but this is someone that talks with thousands of environments around the world about what they're experiencing around keeping data safe in Kubernetes environments. And it is his prediction and the prediction of others that what we're going to see as Kubernetes becomes more critical for commercial private sector enterprises, but of course also for public sector and education enterprises, that we will see attacks on those environments escalate. Now, when we talk about public sector, it's worth pointing out, and probably a lot of you all on the call know this, that if you're in public sector, you've got your own compliance requirements that go beyond what a lot of private sector organizations have to deal with. I'll mention a lot of you are probably familiar with NIST, the National Institute of Standards and Technology. NIST publishes, among other things, the NIST Cybersecurity Framework, which is widely used at various levels of government, both on the civilian side and state and local, civilian fed and state and local. And of course, the controls that sit under the NIST cybersecurity framework are also very closely aligned with the security controls used by the Department of Defense in their risk management framework. NIST first published guidance for containerized security 5 years ago. So containers have now been around since 2013. They've been around for 9 years, or at least that's when Docker first came out, and containers became sort of widely observed. Kubernetes followed just a couple of years after that. Kubernetes is now 7 years old. And just a couple of years after that, NIST first published their security guidelines for how you should properly secure a containerized environment. I will note, those guidelines explicitly call out CP9, Contingency Planning Control 9, in NIST 800-53. NIST 800-53 special publication is the master control set that underlies a lot of different security frameworks that are out there. You see it referred to all the time. In particular, it is the granular controls that underlay the NIST cybersecurity framework. So NIST's specific guidance around securing your container environments refers to the same exact sets of controls around data backup and contingency planning that NIST recommends for any other part of your environment: physical servers, virtual servers, cloud servers, etc. Getting a little bit more specific, NIST 800-171 also calls out media protection for projects that are developed specifically for the U.S. Department of Defense. Now, I know we're on a state and local and education call today, but the fact is the trend in the use of NIST 800-171, that is the control of controlled but unclassified information by private sector organizations, are getting spread a lot wider. A lot of you might have seen the whole rise of the Cybersecurity Maturity Model Certification, or CMMC, a couple of years ago. This is a standard that now applies to over 300,000 private sector organizations worldwide that do business with the U.S. Department of Defense. And it's all around making sure that they have good digital hygiene, that they have good privacy and good security, and good data protection and availability practices in their environment. I'm just mentioning that because what we've seen is this kind of requirement increasingly getting pushed not just to the private sector from the US DoD, but also to other levels of government. So it's relevant that for 5 years now, the National Institute of Standards and Technology has had its eye on container security, and they apply exactly the same standards to that they apply to other workloads. So if we look at capabilities around ransomware protection for Kubernetes, it's probably best to focus first on what the actual challenges are around securing Kubernetes environments. The first of those is how they're deployed. In the current day, backing up VMs that sit on a hypervisor is straightforward. There are plenty of tools out there. I think Veeam is the best, but the truth is there are different tools out there that can protect your hypervisor workloads, whether they're sitting on VMware or on any of the other leading hypervisors that are out there. But Kubernetes uses microservices. They can be running on different nodes that may or may not be on hypervisors. They could be some on physical machines, some on virtual machines. And it's the nature of those orchestrated workloads that they can also be moving around and rescheduled on different nodes. So when you think about what it is you're protecting, what the atomicity is, what the specificity is of what you're protecting, we've gone from a world of protecting a virtual machine to protecting microservices that can be running on multiple virtual or physical servers all over the place. Which means that ecosystem integration, which is the second point here, gets more complex. It's inherently more complex because now I'm dealing with physical nodes, I'm dealing with virtual nodes, I'm dealing with databases, I'm dealing with unstructured data, I'm dealing with some systems that are stateful, that is some applications that are stateful, some that are not, and I've got to balance all of that in my data protection plan. This also means that the scale changes. Obviously, if my unit of atomicity is now the applications, then I get a lot more things that I've got to look at. And that's not just data, that also includes all of the metadata that is relevant in a Kubernetes environment. So I've got to look at things like secrets, I've got to look at network, I've got to look at storage, I've got to look at content maps, I've got to look at all of the things that are not actual applications or data that I still have to have if I want to have a coherent and functioning Kubernetes environment. Now, one of the things that we at Veeam have seen a lot, and we've seen it frankly a lot, particularly since COVID-19, is that when organizations move their workloads to new platforms, there are gaps in how those applications are protected. Many times we saw organizations that moved quickly to get to the cloud. They had to get to the cloud right now when COVID hit. But right now and exactly right are not the same thing. And so we've seen a lot of organizations move to new platforms that had real gaps in what they were, the way that they configured security and the way that they configured protection. Just to provide another data point about this, the World Economic Forum posts a study every year called Global Risks. And what their report this year, 2022, revealed that human error was a factor in 95% of data breaches that they had surveyed in the previous year. So we got to look at the gaps that we're leaving in the environment. That is particularly a challenge for Kubernetes because Kubernetes and containers were designed particularly around developer productivity, not necessarily around infrastructure security. I'll give you just one example of that. The default pod-to-pod network settings for one example, allow open communication so that you can get a cluster up and running in Kubernetes very quickly. But obviously, fully open communications come at the expense of good security. So we have a completely different environment. We have a completely different scale. We have a very dynamic allocation of workloads and data. And we have folks running that environment, in most cases, 78% of cases, according to one survey, whose primary responsibility is not what maybe a lot of your primary responsibilities are, what a lot of Veeam customers' responsibilities are, which are around running the platforms that the workloads are running on and securing them and backing them up. But their primary job responsibility is DevOps. It is actually getting code out, iterating code rapidly, making sure that the code works. And so we've got folks who are running in the security of environments and the data protection of environments for whom security and data protection has not previously been their primary job. And so all of those lead us to an environment where, to cite one survey, the 2022 Red Hat State of Kubernetes Security Report that came out beginning of this year, 22% of surveyed organizations running Kubernetes said that they had failed a security audit in the previous year. So if you think about that, if you've rolled out Kubernetes, if you've rolled it out quickly, your odds may not be that good that there are no gaps in your environment as it's been set up. If we dig into this a little bit more about why Kubernetes environments are vulnerable to ransomware, Kubernetes environments frequently use open source libraries. You might need to be scanning those frequently. Even if you have apps that you trust, Kubernetes is a young ecosystem. A lot of times administrators allow too much permissions for a given app that can be exploited. Gartner has also estimated, kind of in line with the World Economic Forum, that 95% of cloud security incidents through 2025 are going to be due to configuration errors. So if we've got a new environment with folks running it who are used to moving fast and whose primary responsibility has not historically been security, it makes it much more likely that we might run into gaps or omissions in our security policy. Even with all this known, a lot of organizations that deploy Kubernetes overlook the need to back it up. And in part, this may be because they're deploying Kubernetes solutions in the cloud. And one thing that we at Veeam have found pretty consistently is that when organizations deploy workloads in the cloud, they often assume, because of the ability to work across different availability zones, because of the native security and resiliency of cloud environments, that they've got their data backed up. That is not the case. The shared responsibility models from all public cloud providers make it clear that's not the case. That's a whole different conversation, but it is a subtlety that is lost on a lot of teams when they put their workloads up in Kubernetes in the cloud. So if we dig into this a little bit more, there are 4 key requirements that you need to look for, in Veeam's opinion, when you when you put a Kubernetes environment in place to secure it from ransomware. The first of those is backup integrity. I mentioned the Veeam Data Protection Trends Report a little bit earlier on when we looked at Kubernetes adoption rates. The Veeam Data Protection Trends Report this year, we also asked those 3,400 respondents, if you had a ransomware attack in your environment, in what percentage of cases did they attack your backup storage? The answer was in 94% of cases where a ransomware actor got on the network, they attacked the backup environment. Now, the success rate that they had varied. Some folks have more resilient, hardened backup environments than others do. But the point is, you can basically guarantee that if a malware actor gets on your network, in addition to targeting your production Kubernetes environment, they will also be looking to destroy your backups. If they want to hold you for ransom, they'll be doing that so that you have no choice but to pay the ransom, obviously. The second requirement specific around ransomware recovery is accelerated recovery. We are long past the days where a recovery from backup means restoring a single workload or a single file. In many cases, what we're looking at now, in particular in the age of ransomware, in particular with highly distributed complex environments like Kubernetes environments, we're looking at a requirement to restore an entire application and all of its data from backups because we don't know which of the parts of the environment we can trust after a malware or ransomware actor has gotten hold of it, right? We must recover at scale. We must recover from on-prem and off-prem components. And we've got to do it with hybrid infrastructure, with different vendors providing servers, storage, different parts of the ecosystem. So it's really important that we have the ability to recover rapidly at scale, because obviously the cost of a ransomware attack goes up the longer you're down. The next key thing is easy operations. Ransomware is a disaster. You're going to have a lot of visibility from every part of the organization if you get hit with ransomware. And the last thing that you need is the folks that are running your platform operations having to cobble together a response that's partly based on storage, partly based on scripts, partly based on restoring VMs or physical servers from a variety of tools. You need an easy interface that makes it fast and reliable to get back up and running. And the final thing that we heard when we asked our customers, what do you need, is obviously cost effective. I don't need to tell customers in state and local government and education that budgets remain tight, even with some of the pandemic tech modernization grant money that a lot of you on the call have been able to get access to. It's not like budgets are unlimited. So you need tools that are multi-purpose and they're cost effective for what you want to solve. We're going to look at all 4 of these requirements in detail and how Kasten solves for them. But before we do that, for those of you that are not familiar with Kasten, I'm going to give you a quick overview of what Kasten actually is. Probably many of you are familiar with Veeam. We have led in the backup of virtualized environments, and now we lead in the backup of most environments, both in the cloud and in your data center that are out there. If you know Veeam, we have protected multiple workloads simply for a long time. Kasten basically just adds the ability to protect containerized workloads on Kubernetes to the many software as a service, cloud, physical, and virtual workloads that Veeam has already protected. We do that in multiple environments going across both on-prem and in the cloud. We do it with multiple data sources. It has been easy to get application consistent backups of your VMware and cloud and physical server environments for a long time with Veeam. All that Kasten does is take that exact same trend that you've seen and known with Veeam and apply it to your Kubernetes environments. And finally, we do it without locking you into specific hardware configurations. We like to joke that we revolutionize Kubernetes backup. We take the ransom out of ransomware because we don't hold you hostage to using a specific hardware tool if you want to recover from a ransomware attack. Going a little bit further, we talked before about how Kubernetes changes the game when you're backing up from backing up virtual machines or physical servers or databases as an application to the overall application with all of its components, including metadata components, as the level of atomicity, as the underlying level that you need to protect. Kasten is itself a Kubernetes application, so it runs in the clusters that you're protecting. It can support and protect multiple clusters in your environment. And because it's running with applications as the operational unit, it's very easy for it to automatically capture and protect applications, exactly the same way that Veeam, for example, can automatically and protect new VMs in your hypervisor environment. Kasten does not rely on specific tools that address the underlying infrastructure. We've got a lot of deep integrations with different storage and cloud and Kubernetes platforms, but we don't lock you into using just one of them if you want to get your data protected. We are agnostic, just like Veeam is hardware agnostic. And finally, because Kasten runs at the level of applications, it can coordinate its operations across all of the different levels, across all the different infrastructure components that are out there. Now, I mentioned before why it's critical to have easy operations when you're doing data protection, when you want to recover from ransomware. I think this will probably be fairly obvious to all of you when we talk about the differences between Kubernetes and other type environments. But if I'm protecting using VMware specific tools, yes, I can protect my data stores. But if I've got different components of the application that are running maybe on cloud services or that are running on physical servers, a VM level solution is not going to protect those. If I aim to script a solution, I'm going to run into the same issue that I think probably all of us have seen for decades now with scripted solutions. It leaves the organization completely dependent on whoever wrote those scripts, and scripts are very, very prone to getting out of date rapidly. It basically takes away all of the capability that you have, all the automation, all the folks working in the background to make sure you stay protected that you get with a commercial product like Kasten. And finally, there are storage-based solutions for protecting Kubernetes out there, but because they work at the level of granularity of the storage, they do put the ransom back in ransomware because I'm locked into a given storage provider, and they also have issues with management complexity and with a lack of granularity and fault isolation if I want to solve problems in my environment. Overall, we think it's a lot better to actually solve Kubernetes problems at the level of the application, the same way that we thought 13, 15 years ago that it was better to solve VMware backup at the level of virtual machines and the hypervisor. And so that's what we do with Kasten K10. Basically, continuing this theme, if you look, it doesn't matter what the data services that you're relying on are underneath. They could be in the cloud, they could be unstructured data. It doesn't matter which distribution of Kubernetes you're working with. Of course, we do rely on Kubernetes, but we support OpenShift. We support OpenShift up in the public cloud. We support GKE. We support Amazon EKS. We support AKS, Amazon, IBM IKS, etc. across the line. And we do it with a lot of options around storage. And we're going to talk about storage next because that's how we solve requirement number one that we looked at earlier, which is backup integrity. The Kasten answer to backup integrity is to use Veeam's built-in capability to leverage immutability in storage. And because Kasten integrates deeply with Veeam, especially with version 5 that came out over the course of this summer, we can do that in a couple of different ways. If you are already a Veeam customer and you're using our hardened Linux repository on-prem, you can use the hardened Linux repository to protect your Kasten data to make sure that it's immutable. If you're a Veeam customer that is leveraging the way that Veeam can use object lock in compliance mode with S3 or S3 compatible storage, then you can use either in the cloud, that kind of object lock, that kind of capability to provide immutable backups. You can do that with AWS. You can do that with things like Seagate Live Cloud or Wasabi. Or you can do it with on-prem solutions like MinIO or Cloudian or a host of other ones. I'm going to pause for just a second to explain what we mean by immutability and why it's so important. You have to assume if a malware actor gets on your network that they've been on the network for some period of time. That period of time might have been a week. More frequently, it could be something like a month or 2 months or longer. We talked about before one of the main goals of that malware actor, of the ransomware adversary on your network, being to delete your backup data. Now, you have to assume that if they've been on the network for weeks or months, they have managed to escalate privileges to spread through the environment, and they'll have administrative privileges on some set of systems in the environment, potentially including Active Directory, potentially including your backup systems, potentially including your storage admin credentials. What you need if you have immutable backups, if you want to be really safe from a ransomware actor, is the ability to make sure that even if someone compromises all of those credentials, they still can't delete your backups. And that's what S3 Object Lock in compliance mode, whether it's up in cloud-based storage or on-prem in S3 compatible storage, gives you. That compliance mode, it was specifically designed for regulatory compliance. It was specifically designed so that once data was put in buckets that have that enabled, neither the vendor, that is Amazon or Wasabi or the on-prem storage vendor, nor your admins could delete that data, that it was safe, that it was write once, read many, secure for compliance purposes. And it turns out that is a perfect solution to protect against ransomware. And as I said, Kasten's got a couple of ways to do that, both with object lock in compliance mode on S3 storage, or with Veeam's hardened Linux repository, which uses some Linux safeguards to do the same thing. If we dig into the next requirement that we've got, easy operations, Kasten solves that requirement for ransomware recovery by being built for Kubernetes operators, for DevOps operators from the ground up, because it doesn't require you to cobble together a bunch of scripts or go outside of the wheelhouse of your Kubernetes team to start interfacing with storage overlays and things like that. It is much more reliable, much more sure that you can easily recover, that you can easily protect and easily recover when you need to. If we look at the next requirement, policy-based automation, you need a way to make sure that I can both automate the protection of data, but maybe equally important for rapid recovery, that I can automate the recovery of that data, either in the same location, that is on-prem, or off-prem to another data center or to a cloud. I'm not going to dig in huge detail into all of the features in the K10 platform. I'm just going to go through them. But I will point out API-driven automation and the ability to apply policy and automation to every step of my backup and my disaster recovery and my mobility processes is something that was built into K10 from version 1. Kasten K10 has had this, and we have numerous customers that have used Kasten for complicated backup, disaster recovery, and data migration projects, and they've done that at scale. We'll look more at that in just a minute. But if we look at the fourth requirement that was mentioned, of course, that's cost effectiveness. Because Kasten is a 100%, Kasten K10 is a 100% software-based product, we do not lock you into hardware solutions to make sure that your data is protected. We don't lock you into one cloud platform or one hardware storage platform to make sure that your data is protected. In fact, one of the leading use cases that we have seen customers use for Kasten K10 is to migrate between different versions of their Kubernetes platform of choice, or to migrate data from on-prem to the cloud, cross clouds, or to migrate workloads back on-prem from the cloud. The only reason that that's simple to do with Kasten and cost-effective to do with Kasten K10 is because, like Veeam, it is a 100% software-based product. Now, I'm going to give you a use case for this. We're going to look at a case study. This is from Soprasteria, which is a top 3 French IT firm. They are heavily in on their Kubernetes environment, specifically around OpenShift and Ceph, running up in AWS. They are taking advantage of multiple AWS services. Before they rolled out a solution based on Kasten K10, they were trying but having difficulties in protecting that environment using native services, using scripts up in AWS. What they ended up doing was rolling out Kasten K10, and you can see the scale of this. The number of objects, the number of specific components that were being protected, including both data and metadata and applications, was close to 20,000 for the specific set of apps that they were doing, close to 112 different components of different types per application. Now, they rolled out Kasten K10 specifically because it was targeted at their DevOps team. We mentioned ease of use before, and they knew that they would be able to keep most of the focus on what was actually providing value for their customers and providing revenue to the firm, that is their development effort, instead of keeping the plumbing going with platform operations folks. And you can look, the ratio that they had on their teams was 700 developers to 200 platform operations folks running backups, which is actually a pretty amazing and pretty cost-effective ratio that they were able to drive. Even better, they were not just able to use Kasten K10 for backups in this environment, but they also used it for a large OCP, a large OpenShift compute platform migration from OCP 3.x to OCP 4.x. And that included a diverse stack of components sitting on top of OCP, including some databases that are getting a little bit long in the tooth, or application languages, programming languages like COBOL that are out there. So a lot of things were in the environment, a lot of moving parts, a lot of complexity. And again, the main thing that Soprasteria found was that because it is API driven, because the user experience and the user interface are absolutely leading edge and world class, they were able to drive really great developer to operator ratios and have a much more reliable both migration and data protection solution than they'd done in the past. Now, that's a private sector example. I'm going to mention briefly a public sector example. This is federal, and it comes from the large US federal systems integrator Leidos. Leidos has a case study. I'll give you the link for that later on. They do a lot of application development and application modernization products for federal customers, including for DoD customers. And we mentioned before the requirements under NIST Special Publication 800-171 that relates to the protection of controlled unclassified information by organizations that are doing business with the federal government. The fact is, if you're building an app for the federal government, if you're going to be dealing with the US DoD, you have to be able to show that you can protect not just the data, but you also have to show that you can protect the applications and different versions of the application itself. In other words, all the things that are listed on this in the Soprasteria example, things like secrets, services, image information, configuration, all of that metadata that are part of the application but aren't necessarily the end user data. You've got to be able to show you can protect that and you can protect different versions of it. Leidos has a great case study at kasten.io. You'll see the link in a minute here that you can look at specifically for public sector about how they baked Kasten K10 into their application stack to protect large virtualized Kubernetes environments that they were rolling out for federal customers, either in the public cloud or on-prem for applications that may be data gravity or classification level or whatever the case may be, required to remain in government data centers. Now, digging into this a little bit more, if you're interested in more information, or if you'd like to get your hands on Kasten K10 and try it out, the QR code here and the links make it very, very easy to do. We'll have some more examples of resources on the next page. You can go to our industry-leading hands-on lab and actually take it for a test drive without putting anything in your lab or in your home lab environment. You can test drive it. You can also, in keeping with Veeam's Community Edition that we've had for years, you can download a copy for free and use it in very small environments forever, basically, so that you can just learn it and proof it out and make sure that it's going to work. And then when you want to roll it out in your larger environment, you can do that. And I know we mentioned this before, but that's true, and it will work whether you're doing it on-prem or whether you're doing it in any of the large cloud Kubernetes instances or implementations, deployments that are out there. A little bit more information about where you can get additional resources. We have a ton of general Kubernetes instruction information out there at the kasten.io website. Take a look at this URL here, kasten.io resources. And please feel free to reach out if you've got additional questions, if you have deployed Kubernetes, if you've got questions about how to protect it. We've got sales teams, we've got technical teams that are happy to help with that and to make your journey into secure, ransomware-proof Kubernetes deployment an easy and safe one. So we're at 46 minutes in. We want to leave some time for questions. I hope that this has been helpful. Please do reach out if you've got any questions for us today after the webinar. We'd love to answer them for you. And in the meantime, thank you very much for joining. Really appreciate your time.
Loved your timeline to container slide and the way you framed that. Nothing ever goes away. I think of all the mainframes that are still out there. Those were legacy when I got involved in this business back in the late 90s, and containers are now definitely finding their use cases, but it's like something doesn't replace anything. It just all gets added to other stuff.
Well,
That's great for me.
you probably saw, Scott, that IBM reported great Q2 results on this past Q2 on the strength of their mainframe business. So if that doesn't show that technology never fully goes away, I don't know what would.
Absolutely. So I've got a philosophical question for you about Kubernetes and ransomware. So when it comes to Kubernetes and ransomware, right now, is it a matter of the container in the Kubernetes environment requiring specialized backup procedures because it's a different architecture than virtual machines, and that when ransomware sort of hits the whole agency or the whole organization, if you don't have your containers backed up properly, you can't get that data back, using your old processes? Or is it that ransomware attackers are finding ways to come after the Kubernetes itself due to, novel vulnerabilities or common mistakes in Kubernetes configurations?
Well, it's both. It's both. As I mentioned before, there's the whole focus of Kubernetes, and correctly so, in the way that it's been rolled out, is on developer productivity. The idea, well, I mentioned this before, Kasten is itself a Kubernetes application. It is on a 2-week release cycle for little incremental releases. So the whole continuous innovation, continuous deployment cycle is part of Kasten itself, and it's part of what our customer base has. And we've all gotten used to it, right? Logging into Microsoft 365 as an example, from one time to another, that there, on an almost daily basis, there are things that are being changed in the background that are being fixed. That's just the way the world is now. So yes, it is a fast-moving environment, and so we have to protect it. We all have to be vigilant and looking out for it, and that speed does open up vulnerabilities. So yes, it's in part because things change more quickly than we might be used to. In particular, and I've worked with public sector customers for a long time, I know all of you have that are listening to this call have either dealt in the past with or currently deal with applications that you got running and got the authority to operate on the network, a year ago, 3 years ago, 5 years ago, whatever. And the reigning conventional wisdom has been, don't touch it, because if we do touch it, then we've got to go back and get another ATO for it to run on the network. And that way of working does not in any way match what you're going to get and what you want to get from Kubernetes environments, from cloud native containerized environments. So yes, the speed is frequently a radical, enormous difference from what we see in legacy type environments. But the other issue was also one that you pointed out, Scott, and it's exactly correct. That is in part, and I know I mentioned this in the presentation, but in part because I could have in one application stuff running on physical nodes, stuff running on virtual nodes, stuff running in structured and unstructured data, stateful and unstateful containers processing those workloads, cloud services involved in those workloads. What I don't want to find myself doing if I have to restore my entire application suite because it's all being held for ransom by some criminal is that I have to cobble together scripts or disparate recovery tools to cover all those different places my data could come from. What's really, we think at Kasten, the only practical solution is to go from the application level, because it already sees all the things that are part of the application. And if you work from the level of the application, then you're not going to miss any steps that cause your application to be useless when you've got to get the whole thing back.
That's a great point. Great, thank you. Next question, we have one here about how is Kasten K10 licensed?
Oh yeah, thank you. Good question. So we didn't talk a lot about the whole deployment model of Kubernetes. Again, I mentioned up front that we had only a couple of questions about that in the pre-event survey. Mostly they were about the more detailed stuff that we did cover in the talk. But when you're deploying Kubernetes, and any of y'all that already have this deployed know this, a sort of basic level of granularity in what you deploy is a node. And a node basically is something that looks like a server. It is either physical or virtual hardware with an operating system on it. That could be some flavor of Linux, it could be Windows, doesn't matter. It just depends on what your application requires. But Kubernetes is licensed by node. So if I have, 10 nodes in my Kubernetes cluster for a given application, and I want to protect that application with kasten K10, I just need to license it for those 10 nodes. And we make it simple to license. It is subscription based. So it basically follows, we're a cloud native app, and it follows the sort of whole cloud native protocol that I'm sure you all have seen out there, where we're subscription based, and you just buy a year subscription for every node that you need to protect workloads on.
Okay, super. Let's see. Another one here. Does kasten work with on-premises VMware, Tanzu, Kubernetes environments?
Yeah, thank you very much. We actually have, and the link, the sort of kasten.io resources link that was late in the like one of the last slides in the deck, I think maybe the last slide before the thank you slide. If you go there, we have a library of recent webinars, and one of those recent webinars is all about, it's by Adam Berg, who's one of our senior systems engineers at kasten, really deep, strong knowledge of the space and of the technology. And he talks, and previous to that, strong knowledge of both storage and Veeam technology too. He talks about using kasten K10 to protect VMware Tanzu environments. It is absolutely something that we protect. That on-prem, if you're using Red Hat OpenShift container platform, I know I mentioned in the Soprasteria slide that we handled a big migration between OCP3 and 4 as part of the Soprasteria project. But yes, the popular on-prem Kubernetes platforms, we not only support, but usually have deep integrations into those specific capabilities that those platforms bring to bear. Okay, great. Well, Jeff, one other thing I want to, just remind everybody in the handouts, the slides are available there. We are wrapping up here, so if you're interested in some of those links, be sure to grab that deck from the handout section. But Jeff, just as sort of a parting shot, any recommendations for how people can get started with kasten? Yeah, take a look at the links in the deck that I shared. We have a hands-on learning lab that covers not just how to use kasten, but that actually covers a lot of free instructional material about Kubernetes itself. So if you're just getting started in this direction, or if you've been tasked to get started in this direction because you want to update some legacy apps to cloud-native Kubernetes containerized applications, we really believe strongly in giving back to the community. And so there's a lot of free resources there, not just around our product, but around the whole ecosystem. So take a look there. That includes being able to download for free and use on up to 5 nodes in your own environment. So if you've got a home lab or a small lab at work and you want to play with this on 5 nodes, you can download basically fully functional kasten K10 for small dev test environments too. Okay. All right, great. Well, Jeff, I just want to pass along Rudy and Deb and Sandy and somebody else who, the comments are coming in fast and furious, and they've gone off the edge of my screen, but they all offered kudos on what a fantastic presentation this was. Thanks so much for coming on and giving us this update on this really timely issue of how to protect Kubernetes environments against ransomware with Veeam and kasten. Great, my pleasure. Thank you so much, Scott. All right, and with that, before we wrap up, we do have one more piece of business. It's the $300 Amazon gift card. The prize drawing, and the winner of the gift card today is Justino Burgos from Mississippi. So congratulations to Justino. We'll be in touch to get you your card. And with that, on behalf of the Actual Tech Media team, I want to thank Jeff and the entire Veeam team for making this event possible. And thanks as always for attending and for your great questions. That concludes today's event. Have a great rest of your day.